Welcome to this explainer. Okay, so if you've ever felt like your company's processes are just this massive tangled web that nobody actually understands, you're going to absolutely love what we're covering today. We are diving into Osamu Okamura's fascinating 2026 paper on solving corporate inefficiency. Basically, he's proposing a radical shift, moving away from our standard, clunky management tools and moving towards something he calls knowledge-driven modeling. Specifically, it's a three-layer architecture designed to finally map all those invisible dependencies within modern businesses.
Because, let's be real, think about the visceral frustration of modern operations. We've introduced countless tools, software, new systems. We've digitized absolutely everything. Yet, paradoxically, we understand almost nothing about how it all truly connects. You know the feeling, right? Waiting 2 agonizing weeks for a simple project approval, only to find out it was stuck because of some hidden dependency between engineering and procurement that literally no software could flag for you. Individual tasks? Sure. They're lightning fast today, but the moment a project crosses departmental lines, it just enters a void. Honestly, no single person in the organization knows how every piece of the puzzle fits together anymore.
Okay, let's quickly look at our roadmap for today. We'll start by diagnosing the problem, what Okamura calls the structural black box, and see why our old tools are failing us. Then we'll ascend through the 3 layers of his architectural solution, the ontology, knowledge graphs, and graph databases. And finally, we'll look at a real-world transformation to see just how powerful this framework really is in action.
All right, section 1, let's diagnose our modern corporate patient, the structural black box.
So Okamura defines structural black boxing as this state where business processes and information flows are just so intensely complex that the overall dependency network simply vanishes from human sight. It's totally invisible. Imagine trying to build a massive skyscraper, right? The plumbers, the electricians, the framers, they all have their own highly specific blueprints, but absolutely nobody holds the master blueprint for the entire building. That is exactly what's happening in our corporations today. We might have optimized the individual worker, but the structural connections between departments, they've devolved into a tangled, unmanageable mess. The big picture is just completely lost.
And the symptoms of this disease? Well, they're painfully obvious in our day-to-day work. You've got departmental silos operating in a total vacuum, only caring about their own metrics. You get unseen information stagnation, projects just sitting in an invisible approval-waiting purgatory simply because someone went on vacation. But honestly, the most painful symptom is the endless rework chains. A single, seemingly minor design change in engineering, say adjusting the dimensions of a component by just 2 millimeters, triggers this massive domino effect. It literally forces procurement, manufacturing, and QA to blindly start over. We're wasting thousands of hours simply because nobody could predict the impact of that systemic change up front.
Which brings us to section 2, the limits of traditional maps, and the tools we're currently using to try and fix this mess.
We are essentially trying to navigate a hyper-complex, constantly shifting enterprise using the equivalent of a static paper map. Traditional tools, like your standard flowcharts or design structure matrices, they're fantastic if you're dealing with a simple process of maybe 5 to 10 steps. But try drawing a flowchart for a manufacturing process with 500 moving, changing, interconnected steps. It instantly becomes a meaningless bowl of spaghetti. These old maps just can't account for live traffic, multidimensional data, or sudden project changes. What Okamura argues here is that we don't need a prettier paper map, we desperately need a dynamic GPS. We need knowledge-driven modeling to track these dependencies in real time.
So section 3, how do we actually build this GPS? Well, that starts with layer 1, the ontology.
Actually, before we deep dive, let's briefly lay out the entire 3-step architectural framework so you have the big picture in your head. Step 1 is the ontology. Step 2 is the knowledge graph. And step 3 is the graph database. You can really think of this beautifully logical progression as the rulebook, the blueprint, and the engine. Let's begin with layer 1, the ontology. You can think of this as the DNA, or the standard dictionary and rulebook for your specific business domain. Now, you might be wondering, why do we even need this? Well, because computers are completely literal. They do not understand office politics, unwritten rules, or implied workflows. If a computer system is going to actually understand our business, we have to formally define what a task is, what a department is, and exactly how they are allowed to interact. We basically have to map the literal rules of reality for the system.
But the real magic of this ontology lies in the edges, the actual connections between things. Sure, we have our core nodes like tasks, deliverables, departments, and IT systems, But we don't just draw a generic line between them, we define exactly how they connect. Does a task produce a deliverable? Does it consume a component? Most importantly, we define the generates rework edge. This one is absolutely huge. For example, if engineering changes the voltage of a battery, it doesn't just casually connect to the chassis design, it actively generates a rework loop for the physical casing. Defining these specific relationships sets the mathematical rules for how a single change in one task forces a redo somewhere entirely different.
All right, moving on to section 4, layer 2. Now we take those rules and build our knowledge graphs. So if the ontology is the rule book, the knowledge graph is the actual built house. This is the integration layer. And I really want you to appreciate the sheer chaos that gets wrangled here. We take real, messy, unstructured company data, stray PDF operational manuals, legacy ERP systems, project management software, PLM systems, and we force all of it onto the strict rules we just defined in our ontology. We are quite literally turning a scattered digital landfill into one massive interconnected web of singular truth.
Just to give you a sense of the sheer scale we're talking about here, in Okamura's real-world manufacturing case study, building this knowledge graph generated 2,450 unique interconnected nodes and over 6,800 edges. No joke. Imagine trying to hold 6,800 overlapping rules and dependencies in your head during a weekly status meeting. It's humanly impossible, right? This isn't something you can just sketch out on a whiteboard anymore. It becomes a living, breathing digital twin of the company's entire workflow.
Which brings us to our final component in section 5, layer 3, graph databases. Because having a massive web of data is totally useless if you can't navigate it, right? The graph database is the computation layer. It's a database specifically optimized for storing and instantly traversing these deep, complex relationships. Think of this layer like running a 3D stress test or a full-body MRI on our business blueprint. Instead of a poor project manager spending 3 agonizing weeks cross-referencing pivot tables and email threads just to see what might break, the graph database can traverse those 6,800 connections in literal milliseconds. It allows us to ask incredibly complex what-if scenarios at lightning speed.
With this engine running, you suddenly get mathematical, analytical superpowers. First up, impact propagation. If you change a single material spec on a product, the system instantly traces the exact blast radius of that change across all 2,450 nodes, telling you exactly who needs to be notified. Second, centrality analysis. It mathematically flags the true bottlenecks. Maybe it finds that one specific manager is unknowingly acting as a gateway for 80% of all project approvals. And third, cycle detection. It spots closed loops where a process feeds back into itself, causing infinite rework, way before the project even starts. We are entirely replacing gut feelings and guesswork with sheer mathematical precision.
Section 6. Let's look at a real-world transformation and see what happens when this theoretical framework actually hits the ground.
When this was applied to a real manufacturing firm, the results were simply staggering. The time it took to assess the impact of a design change dropped from 14 days down to just 3 days. That is a 79% reduction in pure waiting time. And because they could predict exactly what would break before they made a change, their rework rate plummeted from 1.5 times per project down to 0.4 times. Overall, the total lead time for a massive manufacturing project shrank from 27 months to 22 months. Cutting 5 entire months off a product's time to market is a massive competitive advantage, and it was all achieved simply by understanding how the business actually connects.
So how did they actually get those results?
Well, the graph database diagnosed 47 completely hidden dependencies that nobody in the company even knew existed. It mathematically proved that a specific design review meeting was a massive bottleneck, scoring a 0.82 in centrality. In plain English, that means the single meeting was basically a giant traffic jam for the entire company. And perhaps most importantly, the system found infinite rework loops happening between the design and purchasing departments. By identifying these endless ping-pong matches, management forced the creation of conditional exits. These are hard rules that finally stop a project from endlessly bouncing back and forth.
Which leaves us with this final provocative thought to take away. Are you managing your business with a static map or a dynamic graph? In a world where operational complexity is only increasing, relying on paper flowcharts is just a guaranteed recipe for blind spots and endless rework. And what is so incredibly exciting about the future is that Okamura's vision points toward using large language models to automatically ingest your company's emails and manuals to literally generate these graphs for you. The technology is here, the architecture works. It's time to finally light up these structural black box. Thanks for joining me on this explainer, and keep exploring.